The lanterns were still burning when the survey team entered the lower shaft, despite records confirming the mine had been sealed for over 3 decades. The flames were steady, no flicker, no distortion from airflow, no visible fuel source sustaining them. The problem was not that they were lit. The problem was where they were lit. They hung along a descending corridor that had collapsed years earlier, buried beneath a measurable volume of rock that no passage now connected to the surface. The initial contradictions surfaced during a regional subsurface density reassessment. Geological teams had been recalibrating underground void maps after a minor seismic shift altered stress distribution across the region. The abandoned mine appeared in the model only as a compressed cavity, its tunnels marked as fully collapsed, its vertical shafts sealed by accumulated debris. Yet the thermal scan, layered over the model, showed discrete heat points. Not residual heat, not geothermal bleed. Structured heat, evenly spaced, repeating, following the original tunnel layout. At first, the readings were attributed to sensor misalignment. Subsurface mapping systems can produce mirrored artifacts when calibration drifts across layered rock densities. A correction pass was scheduled. The anomaly persisted. The pattern did not blur or shift as expected under recalibration. It remained fixed. More concerning, the heat signatures matched known lantern spacing documented in archival diagrams from the mine's operational period. The intervals were too consistent to dismiss as noise. An analyst reviewing the overlay hesitated before escalating. The spacing could be coincidence. Fractured rock sometimes traps thermal pockets, but those pockets do not align with human placement patterns. A second scan was conducted using a different sensor array. The points reappeared. Same positions, same intensity. No measurable decay between scans. At that stage, a physical inspection was authorized, though the decision was not immediate. There was brief internal disagreement regarding access risk. The mine had been classified as structurally unstable, with documented collapses sealing multiple access routes. Entering it required excavation through compacted debris layers. The hesitation lasted less than a day. The persistence of structured heat within a sealed volume could not be left unverified. Excavation began at the upper shaft, where historical maps suggested the least resistance. Removing the overburden exposed the original entry tunnel, though its interior had shifted. Support beams had failed long ago. Sections of the corridor were compressed, others partially open. As the team advanced, they encountered the first indication that the model was incomplete. Air movement. Not strong, just enough to register on handheld instruments. The shaft should have been static. With all lower passages collapsed, there was no through-flow pathway to sustain internal air exchange. Yet the readings showed consistent directional drift. Downward. The team continued. Roughly 40 meters below the entry point, they reached the first obstruction, a collapsed segment where the tunnel had been crushed under layered rock displacement. According to the model, this was where access ended. Beyond it, the mine no longer existed as navigable space. The thermal readings, however, indicated otherwise. Heat signatures continued beneath the obstruction. The decision was made to breach. Careful removal of debris opened a narrow passage. Not enough for full equipment, just sufficient for personnel to pass one at a time. The rock composition within the collapse showed compression consistent with external pressure, but the internal cavity beyond did not match expected deformation. It was intact. The tunnel resumed on the other side. The walls showed age, Mineral deposits had accumulated along the surfaces. Wooden supports, where present, had degraded but remained structurally positioned. Dust coated the floor, undisturbed. And then the first lantern came into view. It was mounted on the wall at shoulder height, exactly where archival diagrams indicated one should be. Its flame was stable. No smoke accumulation marked the ceiling above it. No soot pattern extended outward. The glass enclosure was clean. One of the engineers approached, pausing just short of contact. There was a brief discussion whether to extinguish it, whether to measure output first. The decision was made to observe without interference. The flame produced measurable heat. That much aligned with expectation. What did not align was the absence of fuel consumption indicators. The reservoir beneath the wick showed no visible depletion. No condensation formed along the interior glass despite sustained burn conditions. The air around it did not show oxygen reduction consistent with combustion. The flame existed, but the environment did not behave as though it was supporting it. Further down the corridor, additional lanterns appeared, each one identical in behavior. Spacing matched the original layout. Intensity matched across all units. None showed variation that would suggest independent operation. At this point, the team paused advancement to reassess. A portable analyzer was deployed to sample air composition within the tunnel. Oxygen levels were within normal subterranean variance. Carbon dioxide levels did not reflect active combustion across multiple sources. The data conflicted with direct observation. An assumption was proposed that the flames might not be conventional combustion, that some chemical residue or mineral interaction could be producing sustained luminescence. The proposal did not hold under measurement. The heat output matched open flame characteristics. The light spectrum aligned with hydrocarbon burn. But the environmental impact was absent. The team marked positions and began documenting the sequence. Then something changed. One of the forward lanterns, approximately 15 meters ahead, dimmed. Not gradually. It reduced intensity for a fraction of a second, then returned to its original state. No airflow fluctuation was recorded. No physical disturbance occurred. The dimming was isolated. The team advanced toward it. As they closed the distance, the next lantern beyond it exhibited the same behavior. A brief reduction, then stabilization. The pattern did not move in a continuous sequence. It appeared ahead of them. The corridor extended deeper than expected. According to structural models, this section should have intersected a secondary collapse zone. Instead, the passage continued unbroken. The thermal map updated in real time. New heat points appeared beyond the previously charted limit. The mine, as physically encountered, extended further than its recorded boundaries. And the lanterns continued. At this stage, the operational context shifted. The anomaly was no longer limited to sustained energy presence. The spatial depth of the mine itself was no longer consistent with geological mapping. The team halted progression. Behind them, the entry path remained open. Ahead, the tunnel extended into unverified structure. The lanterns, unchanged in placement and behavior, marked a path that should not have existed. And yet, their spacing remained precise, as if placed with intention. But not recently. The team began withdrawal procedures. As they retraced their path, something else became apparent. The air movement had reversed. It was now moving upward. Not strongly, but consistently. And as they passed the first lantern again, one of the engineers noted something that had not been recorded on entry. The glass surface was warm to the touch. Not from the flame, from beneath. As if the heat source was not entirely contained within the lantern itself. When they reached the breach point and exited the lower section, the obstruction behind them showed no shift. No expansion. No evidence that a longer tunnel existed beyond it. The physical structure, from the upper shaft perspective, remained consistent with the original collapse model. But the thermal scan, updated moments later, showed the lantern sequence continuing deeper. Beyond the point where the team had turned back. And further still. The anomaly had established one fact with certainty. The lanterns were not simply remaining lit. They were occupying a depth that did not correspond to the mine's physical structure. And that depth was increasing. Follow-up mapping attempts did not begin immediately. For several hours after the initial survey team exited the shaft, the subsurface model remained unchanged. The mine appeared, once again, as a partially collapsed structure with a limited accessible depth. The extended corridor the team had walked did not register in any structural scan. Only the thermal layer contradicted that conclusion. The lantern sequence remained visible, and it had extended. Additional heat points now appeared beneath the previously mapped boundary, maintaining the same spacing pattern. The extension was not random. It followed a continuation of the original tunnel axis, as if the mine had been constructed further downward than any recorded excavation. No documentation supported that. Archived records from the mine's operational period were re-examined. Shaft depth, lateral expansions, and secondary corridors had all been logged with precision. The newly observed extension exceeded those records by a measurable margin. A second entry was authorized under controlled conditions. This time, the objective was limited. Verify whether the physical extension persisted or whether the previous observation had been an isolated inconsistency. The same access route was used. The upper shaft showed no variation. Air composition remained stable. The collapsed section was breached again with minimal resistance, the opening aligning exactly with the previous entry point. Beyond it, the tunnel resumed. The first lantern was present. Its flame remained unchanged. Temperature readings matched prior measurements. The team advanced. At first, everything aligned with the previous entry. Lantern spacing, tunnel width, wall composition, all consistent. The sequence of mounted lights continued at regular intervals, marking the corridor with uniform illumination. But the point at which the previous team had halted was reached sooner than expected. Distance markers placed during the initial survey appeared earlier along the path. A recalibration of position tracking confirmed it. The tunnel length had contracted, not collapsed, not obstructed, shortened. The lantern sequence adjusted accordingly. The number of visible lanterns between the entry point and the terminal point was reduced. Yet the thermal scan outside still indicated a deeper extension. The physical and measured depths no longer matched. At this stage, a temporary stabilization was assumed. One interpretation suggested that the anomaly might have reached a steady state after initial expansion, that the extended depth observed earlier had retracted. This assumption held for approximately 12 minutes. Then the terminal lantern, previously marking the furthest accessible point, shifted. There was no visible movement of the structure itself. The lantern did not slide or detach. Its position relative to the tunnel walls remained fixed. But the distance between it and the previous lantern increased. Not gradually, instantly. The spacing expanded by several meters. The corridor did not stretch. The space between objects redefined. The effect propagated backward. Each lantern maintained its mounting position, but the intervals between them adjusted in sequence, increasing the total length of the corridor without altering its physical surfaces. Markers placed along the floor separated accordingly. Distance measurements updated in real time. The tunnel was extending again, this time while under direct observation. The team halted movement. Instrumentation confirmed the change. Laser rangefinders reported increased distances between fixed reference points. Wall composition remained unchanged. Structural stress indicators did not reflect deformation. The geometry of the space had altered without mechanical displacement. One of the analysts proposed that the depth inversion model might better explain the behavior than structural expansion. The mine was not growing deeper in the conventional sense. Instead, the relationship between measured depth and physical position was being altered. The tunnel remained where it was, but the depth assigned to it was increasing. As this interpretation was being discussed, another anomaly presented itself. A lantern positioned approximately 20 meters ahead extinguished. No dimming this time. The flame ceased entirely. The glass enclosure remained intact. No residue, no smoke trail, no temperature spike indicating sudden fuel exhaustion. The light simply ended. The surrounding corridor did not darken immediately. A faint residual illumination persisted along the walls, as if the light had been absorbed into the environment rather than removed. Then, several meters further ahead, beyond the visible end of the corridor, a new lantern appeared. Already lit. Its flames stable. Its placement aligned with the established spacing pattern. The sequence had not lost a lantern. It had repositioned one beyond the current visible boundary. The implication was clear. The lantern system was maintaining a constant count while redistributing itself across an expanding depth framework. The anomaly was not just sustaining energy. It was regulating its own spatial distribution. At this stage, the team initiated withdrawal. Not due to immediate hazard, but because the environment no longer provided a stable reference for navigation. Distance markers could not be trusted. The return path, while still visible, could not be guaranteed to maintain its length. As they moved back toward the breach point, the spacing between lanterns continued to adjust. Not uniformly. Segments of the corridor compressed, while others expanded. The effect did not follow a predictable pattern. At one point, two adjacent lanterns appeared closer together than standard spacing would allow. Moments later, they separated to twice that distance. Throughout these changes, the flames remained constant, unaffected by spatial variation. At the breach point, the exit remained fixed. The transition from the anomalous section to the upper shaft was immediate. No gradual normalization occurred. One step placed the team back into a stable environment where distance and structure behaved consistently. Behind them, the extended corridor remained visible for several seconds. Then, without any structural shift, it shortened. The far lanterns disappeared from view as spacing contracted. The sequence stabilized at a reduced depth. External monitoring resumed immediately. Thermal scans showed continued fluctuation. The total number of lanterns remained constant. Their distribution across depth varied over time. At irregular intervals, new depth extensions appeared, followed by partial contractions. The mine, as recorded in geological models, did not change. The anomaly existed within it, altering the internal relationship between position and depth without affecting external structure. In the weeks that followed, the site was reclassified. Access to the lower shaft was restricted, not due to collapse risk, but due to navigational inconsistency. A new monitoring protocol was established. Thermal mapping of the lantern sequence was assigned continuous observation status. Data collected over extended periods confirmed that the anomaly did not stabilize into a fixed configuration. Depth values associated with the lantern positions continued to fluctuate. In some cycles, the sequence extended beyond previously observed limits. In others, it contracted to near original mine depth. The pattern did not repeat. No cycle matched a previous one exactly. There was a brief period during which the thermal signatures appeared to align perfectly with the original mine layout. That alignment held long enough to suggest normalization. Then the sequence shifted again, extending beyond the lowest recorded shaft depth by a margin that exceeded all historical excavation data. No further entry attempts were authorized after that. Instead, the anomaly was integrated into subsurface modeling as a variable depth region. The mine is still marked as collapsed. The lanterns are still recorded beneath it. Their positions change. Their number does not. And the depth they occupy has no fixed correspondence to the ground above.